Hello? Okay, calculus. Okay, we're going to do some calculus. I'm going to go back over one of the problems, not both of them from this slide. I'll go over B. Okay, so because a lot of people did too many drugs over this last weekend and forgot everything that they're doing. Yes, so yes, cough medicine does count, and so it's not good. Anyway, okay, so I'm going to start this off by drawing my wheel of derivatives. My wheel of derivatives. So at the top of my wheel of derivatives, what do I have? Say sine. Okay. On the right hand side I have? On the bottom?
Negative sine.
And?
Negative cosine.
Very good. So this is my basic wheel of derivatives. I know to do the derivative, I go which direction?
Clockwise.
Clockwise. Okay, so an antiderivative would go counterclockwise. So counterclockwise. So let's go ahead and take a look at this. So the antiderivative of cosine, so if I'm starting at cosine right here, antiderivative would be, say sine. Sine, okay. So it's going to be the sine. So this one right here is going to be the sine of x from 0 to, okay, there we go, 0, pi over 6. Está muy fácil. Sí. All right, so that's pretty straightforward. Almost. Okay, what do we have to do now? Plug it in. Let's plug it in. Okay, we always start with the top though. So on the unit circle, we're going to start at pi over 6, right? So calculus is always in what mode? Radian. Always has to be in radian. Always. Todos. Every day in radian. So we're going to work in radian all the time for this. So given that, so pi over 6 is basically just 30 degrees. Not 30. Yeah, 30 degrees. Yeah, 30 degrees here. So that's going to end up being on my unit circle. So the sine is the y value. So the y value at pi over 6 is going to be 1/2. So this is the top minus the bottom. What is sine at 0? My answer is 1/2. No, it's not. That's just the same problem, but the next one's going to be complicated. Yeah. Will that one make you happy?
Yeah.
Okay, good. All right. So, one and more complication. So, we're going to do C here. So, for C is one of those things on the flashcards that I told you guys that are going to be so important. Anyone still have the flashcards?
Somewhere.
Okay.
It looks like a logarithm.
Nope. Anyone recall?
No.
So, those flashcards are so important. This is going to help you here because we're going to do a substitution from this. Whenever you see something like this, 1 over the square root of 1 minus x squared, that is its own identity. It's an arc. It's an arc.
Oh, it's an arc tangent.
I believe I even gave you those in the notes somewhere.
Yeah, you showed us.
I just can't remember where I gave them to you in the notes.
No, you didn't give
This
them
was
in the
like
notes.
in the
You
very,
gave
like
some-
in the first few pages.
It was like in the third unit or something.
Yeah, I'm trying to back up to see where I gave it to you, but I did.
It was really long time ago.
You did it in a few
I didn't think it was that long ago.
I did it.
It was. It wasn't last unit. It was like the unit before.
Unit before, when we're doing like,
Like the third unit.
okay, anyway. So this right here is going to be arc sine. That one's arc sine. It is just perfectly arc sine. because it's 1 minus x squared. If this right here, we could do some substitution like to make it work, but in this case it's not. This is just arc sine. So this is arc sine of x from 0 to rad 3 over 2. All right, now from the arcs, that means that I'm actually thinking about my unit circle. Thinking about my unit circle. So now think about the signs. So this is going to be a quadrant 1. Where in quadrant 1 is the sign value going to be rad 3 over 2?
60 degrees or pi over 3.
Pi over 3?
Yeah.
Okay, so this is going to be pi over 3
And 0,
minus the bottom side.
1.
So where is sine going to be equal to 0
Pi
at?
over 2. 0 is going to be
0. 0 pi, right?
0 is
0 pi. So 0 pi. So my answer is going to just be pi over 3. So this is probably one of the more complicated because it's something that you guys actually have to try to memorize and go back over, because if we go through and try to make these on the test all the time, you're going to take a whole lot of time. You're going to waste your whole AP test on this.
okay.
So,
Isn't there going to be like pi over 3 plus pi n, because like sine is going to be equal 0? Like,
no, but the
like
interval is only going to be from pi over 2, or negative pi over 2 to pi over 2. Whenever you're doing the arcs, the interval, because in between there it's not
right.
existing.
Answer is
Okay. All right, last one. So this is another one. This is another one. This is going to be a special one here.
This is
So whenever we have this right here, so hey, do you guys mind, please? You know, small class, it makes it even worse. So x to the negative 1, right?
Oh,
Dx, right?
okay. Anyway.
What happens when you take the integration of something? What do you do to your exponents? You add one, but what is that going to do to this one?
0.
It's going to give me x of 0, so that's going to mess up my whole function here, isn't it?
Yeah.
So this one, if you look at it and you're like, oh hey, this messes up, so there's something else wrong here. So whenever I have this, it's going to give me something special. So from this one right here, we don't take the integration like this. It's 1 over x is going to give me ln. So the integration of this is going to be my ln of absolute value x, and it's going to be from 1 to 2. So I put in the absolute values in this case. It's not really necessary because these ones, when I'm talking about a definite integral, it's only going to be between these points right here, and there's not going to be anything outside of it. Whenever you have something and it's just taking the integration, you would leave your absolute value bars. But if we have numbers to plug in there, it's not necessary. Okay, so for this right here, it's going to be ln, okay, top minus bottom. So ln of 2 minus ln of 1. And then ln1 is its own special thing.
Why ln is from the absolute value x?
You know when you're playing on your phone right there? I was just talking about that. So, right here, ln1 is going to give me 0. So if you guys want to test that in your calculator, it is what it is. So whenever I'm looking at this, so ln at 1 is going to be 0. So my whole answer on this one is just going to be ln of 2. All right. So hopefully this is not going to be too bad. Find the area under the graph. So for this problem right here, area under the graph. So to find the area under a graph, I use what? I use the integral, and this balance is going to be from -1 to 1. So the integral from -1 to 1 of e to the x dx. All right, so what is the derivative of e to the x? E to the x. What was the antiderivative? E to the x. So both cases, I'm going to have e to the x. So this is going to be just e to the x from -1 to 1, right? So it's going to give me e to the 1, right? And it's going to become minus e to the -1, which is going to be the same as saying e minus 1 over e. All right, interpret the integral of a rate of change. The fundamental theory of calculus states that under certain conditions, if f, capital F, is an antiderivative of f, then, okay, we have the top minus the bottom. Since f, capital F, is an antiderivative of f, then f prime, so the derivative of f, is equal to f. Derivative of the integral is just the function. Okay, so right here, b to a, so this is going to be, from here I'm going to have, right here it's going to be f of b minus f of a. So the derivative of the integral is going to be f of b minus f of a. The integral changes from a to b of the rate of change of f equals the change in f from a to b. Whole bunch of crap. All right, population of the United States growing at a rate of p prime of t is equal to 2.867 quantity 1.009 to the t million people a year, where t is the number of years since 2015. All right, so now find this one right here. Okay, so what does that mean?
So we need to find a derivative.
Okay.
Oh, that's
From where to where?
from B to A.
Okay, what does the 0 mean?
0.
What does 0 represent?
Initial start.
Say 2015, right? Where I'm starting it, right?
Yeah.
And what does the 5 mean?
2020.
What year?
2020.
2020. Year 2020. Yes, positive 20. The year 2020. 2015, yes. I'm agreeing with you. Man, some people. All right. Anyway, so with that one right there, let's go through, and I'm going to. There we go. And what was the numbers?
There's a lot of zeros.
2.867.
2.867 and it breaks 1.00
1.001
to the
to
t.
the t power.
Oh, and now the antiderivative is going to be just this thing inside
Something like that.
because it's already derivative.
Something like that.
Alright.
I'm actually finding it right here so I don't screw this up.
Not fair.
Hmm?
You have like a cheat sheet.
You do too. It's called a textbook. Oh, there it is. Okay. All right. So we're gonna take a look at this. So what am I gonna do with that number out front?
Take
It
it
goes
out.
to
Take it
the
out of
power.
the integral.
Now it goes out of the
Okay, it can come out, right? So it's gonna come out of that, so that's gonna be 2.867, right? And let's go back a page. So if I have this right here, f of b minus f of a, right? Yes? No? Maybe? And I have the same thing right here, right? So it's going to be f of b minus f of a, isn't it? So f of b. So what's the f of b going to be?
1.0092 to the fifth power. And minus 1, because anything to the 0 power is 1.
Something like that?
Yeah.
Like I said. All right, you guys. I'm finishing this one tomorrow.